So first I'm going to rewrite the equation by taking out the 2, so making a cosine of 2 times x minus pi over 6. So the amplitude is going to be 1/2. The period is going to be 2 pi over 2, which just equals pi. And then the shift is going to be, since it's minus pi over 6, when we write pi over 6. So to start, the original graph would look like just a regular cosine graph. The amplitude of 1. So then we're going to graph the horizontal shift, pi over 6. So we're going to add that to the graph. So this is the graph shifted right, pi over 6. So then next, we're going to graph y equals cosine of 2 times x minus pi over 6. So it's going to be a horizontal shrink by 1/2. And then next, we're going to graph y equals 1/2 cosine 2x, 2 times x minus pi over 6. So that 1/2 is going to be a vertical shrink, 1/2. The next step is going to be to graph negative 1/2 cosine 2 times x minus pi over 6. So there's a reflection there. And then to put it all together, the final graph is going to look like this. And this is also showing the last shift, which is a vertical shift, 1/2. So the next one, the amplitude is going to be 2. The period is going to be 2 pi over 3, and then we're shifting left 1 because it's plus 1. So the first thing we're going to graph is just the original function, y equals sine x. Then we're going to graph y equals sine of 3x, which is a horizontal shrink by 1/3. Next, we're going to graph y equals sine 3 times x minus 1, so that's going to be adding in, or plus 1, it's going to be adding our shift left 1. Then the next step is going to be y equals 2 sine 3x plus 1. So that is showing the vertical stretch by 2. So it's going to turn the amplitude into 3. And then finally, we have 3 plus 2 sine 3x plus 1. So that's shifting up 3, which will make the amplitude 5. I actually wrote this one wrong, but that would be 0 instead of, because it went up 3. So the next one, y equals 1/2 tangent, take out pi, so pi times x minus 1, which would make the period pi over pi, which is just 1. So we're going to start by graphing y equals tangent x as the original graph. And they're asymptotes at pi over 2 and negative pi over 2 in that original graph. So then the next step is we're going to graph y equals 1/2 tangent of x, which is going to be a vertical shrink 1/2. And then the next step is going to be y equals 1/2 tangent pi times x. So that's a horizontal stretch by pi. So that just makes the graph a little bit wider. And then the next step is just to add that shift right 1. So this next one, we're going to take out the 2, so make it -2 tangent, 2 times x minus pi over 6. The period is going to be pi over 2. So we're going to start again by just graphing the original function, y equals tangent of x, the asymptotes at pi over 2 and negative pi over 2. Then we're going to graph negative tangent of x. So that's the same asymptotes, but just the opposite direction, because it's a reflection. And then -2 tangent of x is just going to change the shape a little bit. It's still the same graph, basically. And then -2 tangent of 2 times x minus pi over 6. We have our period change, and then our shift right pi over 6. So we'll graph that. So this is a 30, 60, 90 triangle. So across from 30 is a, across from 90 is 2a, and across from 60 is a root 3. So that means a equals 25 over 2, which means x equals 25 over 2. This is another 30, 60, 90, so it's the same a, 2a, a root 3. So our a equals 13 over 2, so then 13 over 2 times root 3 is going to be our x value. This is another 30, 60, 90. So our a equals 4. So x is 4 root 3. And then this is a 45, 45, 90. So those two sides are equal, a, and then across from the 90 degree is a root 2, so 12 root 2. So for a, tangent is 2 over 3 in quadrant 3, so they're both negative values, technically. So then we're going to use the formula tangent squared of theta plus 1 equals secant squared. So 4 over 9 plus 9 over 9 equals 13 over 9. That's secant squared. So secant is root 13 over 3. And then the inverse of secant is going to be our cosine. So that's going to be 3 root 13 over 13. But since we're in the third quadrant, that's going to be negative. So that's cosine. So secant equals 2 in quadrant 4. The other 5 functions. So sine, cosine, tangent, cosecant, secant, cotangent. If we draw a right triangle, we can label secant, so our cosine is 1 over 2 because the secant is the inverse of cosine. So then we know that adjacent and hypotenuse are 1 and 2. And then we can solve for the opposite angle with the Pythagorean theorem, which is going to be root 3. So then now we can do negative root 3 over 2, 1/2, and then root 3, and then all quadrant 4, so we know it's positive cosine, negative sine. And then cosecant, 2 root 3 over 3, secant 2, and then cotangent, we just need to rationalize, so root 3 over 3.